Welcome to the world of physics. My dear students, we were discussing about our chapter magnetism, and in the last class we were discussing about magnetic field and magnetic lines of forces. And we have studied about the properties of magnet. I have given one homework to write on a white paper the properties of magnet, 5 properties, and I hope that you have done and you have studied. And there was one more homework was there on page number 87. Check your progress. I think magnetic poles always exist in pairs. The second one, the region around a magnet where magnetic force can be experienced is called a magnetic field. And a magnetic field is represented using curved lines called magnetic lines of forces. These are the 3 answers. I hope you have completed it. Today, we are going to discuss about temporary and permanent magnets. The second point what we have to discuss today is magnetizing a magnetic material. Magnetizing a magnetic material. In magnetizing the magnetic material, today we will discuss about 3 methods: single touch method, double touch method, and the final one is magnetic induction. So shall we start with the temporary and permanent magnet? Yes. The word temporary means what? Very short time. That is not last for very short time. And the word permanent means it will be remaining as it is for a long time. This is the difference between the word temporary and permanent. So what do you mean by temporary magnet? In page number 87 it is given magnets that can retain the magnetic properties. Magnet that can retain, that means it can store the magnetic properties only for a short interval of time is known as temporary magnets. The magnets that can store the magnetic properties only for the short interval of time is called temporary magnets. That means we have discussed about artificial magnets are there, natural magnets are there. Artificial magnets are made by human beings. So we are able to make magnets. We are able to make the magnets. Already we have discussed that for the uses, according to our use, we are able to make the magnet in any shapes. Same way, we are able to make the magnet in 2 conditions: temporary magnets and permanent magnets. And the temporary magnets will be magnetized, or it will be act as a magnet only when this magnetizing forces are given. Only when the magnetizing forces are given. That means in the presence of magnetizing forces only the temporary magnet will be acting as a magnet. Whereas permanent magnets means the magnets which are regaining or which are retain their magnetic properties for a long time even after we are removing the magnetizing force. Even after we are removing the magnetizing force. So in a very simple way we can say that temporary magnets are the magnets that can store magnetism only for a short time. Permanent magnets are the magnets that can store the magnetic properties for a long time. Now, what is the magnetizing force we can give in order to make a magnet? The magnetizing forces will be given either by the electricity or the presence of an external magnet. The word vicinity is used there. The magnetizing force could be electricity or another magnet in their vicinity. Vicinity means presence. That means when we are giving a magnet, there will be already in the previous class we have studied that magnetic force, magnetic fields are there. So vicinity means magnetic field, presence. Now, permanent magnets are generally made up of iron, cobalt, nickel, or the alloy called aluminium. Permanent magnets are made up of iron, cobalt, nickel, and the alloys of these elements called alnico. What is alnico? It is also given there. A mixture of aluminium, nickel, and cobalt. A mixture of aluminium, nickel, and cobalt is called alnico. We know that all these elements are already magnetic material, so their mixture also will show the magnetic material, all the properties of magnetic material. Permanent magnets means what? They are retaining magnetic properties for a long time even after we are removing magnetizing forces. Okay, magnetizing forces are provided by either electricity or the presence of an external magnet. This much is clear now. So this is about a permanent and temporary magnet. We are moving to the next topic, that is magnetizing a magnetic material. Magnetizing a magnetic material. But to make sure, that means when we are reading this, the first point you have slide in your mind is that magnetic material. We are able to make magnet only from a magnetic material. That means iron, cobalt, nickel, and the alloy called alnico. That means your wood, that means your scale is that is made up of plastic, wooden piece made up of wood. These both are not magnetic material. Non-magnetic material cannot be converted into magnet. So what is magnetizing? The process of changing a magnetic material into magnet is called magnetizing. The process of changing of a magnetic material into a magnet is called magnetizing. So for magnetizing there are different methods. So today we are going to discuss about first three methods: single touch method, double touch method, and magnetic induction. Single touch method, double touch method, and magnetic induction. So first we will discuss about single touch method. We will discuss about the single touch method. You can look at your page number 87 on your textbook. There is one activity is given, activity 8. So we are going to magnetize a magnetic material. We are going to convert a magnetic material into a magnet. So you want to learn that one now? Surely you will be interested in these things. So in order to convert or in order to make a magnet, I need a magnetic material and an external magnet, magnetizing force. So first two cases we will be using bar magnet. That means these three cases we are using a bar magnet as an external force or a magnetizing force for a magnetization. So first, if it's a single touch method, we will use only what? One single external bar magnet, not south. From there only the word came single touch method. Now, for single touch method, the activity we need three things: a magnetic material, one bar magnet, and a wooden ball, which is made up of non-magnet. Wood is already non-magnetic material right now. So, I am going to consider a needle. A needle which is made up of iron. You know that iron is a magnetic material. And this nail is going to keep on a wooden ball. Wooden ball means you know this is a non-magnetic material. Is it now? Now what you are going to do? You are going to take this bar magnet and you are going to keep this one at one end. Only one magnet, keeping at one end. You can keep either north pole or south pole. As you like, you can keep. Any pole can be kept. But if you are keeping north pole, always you have to keep north pole. Don't interchange the poles while the process is going on. So suppose this is the duster. Suppose I have marked this one as the north pole, and I am going to keep this north pole on the one end of the needle. And what I will do? I will just rub it from one end to the another end. And you should not rub it back. After reaching here, remove it. Again place the first point, rub it, remove, again place the first point, rub it, remove, again place the first point. This is the process by which we are going to convert the magnetic or the needle, iron needle into a magnet. So this process you will be doing maybe 30 times or 25 times you will be doing. After that, after rubbing this one 30 times in one direction with the same ball, you can remove this one, external magnet. You have removed the external magnet. Then what you have to do? Just place some small iron pins near to the needle. Then suddenly you can see that this needle is attracting the iron pins. This needle is attracting the iron pins. Iron pins. It's clear that the magnetic material has converted into magnet. If it is magnet, then only it can attract the magnetic material. Right now, so this iron needle is attracting magnetic material. So this is called a single touch method, the first method of magnetization. So how? Once again, we have taken magnetic material, placed on a non-magnetic material. We have taken one external magnet, kept one of the pole, north or south. If you are giving south, place the south always. And rubbing from one end to the other end, taking away, again rubbing from the first end to the second end, again taking away, rubbing from the first to the second. This will be repeated maybe 30 times, removing the external bar magnet. Then you will see that this iron needle will start attracting magnetic materials. That means iron needle has already become a magnet. This is a permanent magnet. This is a permanent magnet. Clear now? Okay. Now, next one is double touch method. Next one is the double touch method. Then what will be double touch method? As the name says, here we have only single touch, only one external bar magnet. In double touch method, we are going to use two external bar magnets. That's why we are calling as a double touch method. We are going to touch on the needle with the two magnets. So here what we are going to do? Taking a needle, placing at the needle on the wooden piece as the same process. Here, the same time we are going to touch with two poles. Two magnets are there. It is not from one end. We are going to place at the middle. Middle we have magnetic. At middle I have placed the magnet. If first one is south pole, the second magnet will be north pole. The first one is south pole, the second magnet will be north pole. Now what I will do? Suppose if two chalk pieces are there, these are the two magnets which are opposite poles. Placing here on the middle of the needle, rubbing in opposite direction. Taking away, again placing in the middle, rubbing opposite direction. So this process will be repeated maybe 30, 25 times. Then after that, you will remove this both the magnets. Then you will give some iron pins there. You will observe that the needle is attracting magnetic material. So the needle has become a permanent magnet. This is called the double touch method. So in double touch method, what is the difference? We have taken, instead of one magnet, we have taken two bar magnets. Instead of giving it one end, we have kept at a middle. What is the condition? If the first one is south pole, the second one should be north pole. If the first one is north pole, the second should be south pole. Then we have rubbed from the middle in opposite direction. Again, taking to the middle, rub in the opposite direction 30, 25, 30 times and removing the magnet. When it is the magnetic materials are placed nearby, already it is attracting. That is called the double touch method. That's called the double touch method. The last one is magnetic induction. What is magnetic induction? These two things are we are making permanent magnet. Now we are going to speak about the temporary magnet. The temporary magnet is made by magnetic induction. Magnetic induction. You can look at the page number 88, activity type. Here, I have a wooden board. With the wooden board, I have placed some pins, paper pins I have taken. Then, I have placed a stand. On the stand, I am going to place a big iron nail. Big iron nail I am going to place. Now, I have this. When the iron nail is kept here, this is a magnetic material, this is also magnetic material. Will the iron nail will attract this magnetic material? No, it is not going to attract a magnetic material because both are magnetic materials, they are not magnets. Now, I am going to take one bar magnet and touching on the tip of the iron nail. Maybe north south pole, but which any pole you can touch. When you are touching with an external magnet, suddenly what will happen? This the iron will be attracting the small pins. Clear? The iron nail is going to attract the small pins. If you are removing this magnet from the iron nail, what will happen? The magnetism vanishes, pins will fall down. Again, if you keep the magnet on the top of the iron nail, again these pins will be attracted. As you remove the magnet, the pins will be falling down. Is it done? Yes. So this is called magnetic induction. On page number 88, the definition is given. Magnetic induction is the temporary magnetization of a magnetic substance under the influence of a magnetizing force. Under the influence of a magnetizing force. And once you have removed the magnetizing force, all the properties of magnetism is vanished and the pins are falling down. So it is called a temporary magnet. Whereas single touch method and double touch method, even after we have removed the magnetizing force or removed the bar magnet, then also the needle was able to attract the magnetic materials. So this is called a single touch method, double touch method and magnetic induction. These two are making permanent magnets, whereas magnetic induction will give you temporary magnets. This is about our today's topic. So we have learned about the temporary and permanent magnets and magnetizing a magnetic material. So next today we will be discussing about how now electricity, how can we use electricity as a magnetizing force. Okay, now one small homework is there. That means double touch method and single touch method. Page number 87, activity 88, activity 8 and page number 88, activity 9. These both figures, two figures are there, 7.13 and 7.14. These both figures you have to draw on a paper, white paper, A4 size paper, two sides, and briefly explain what is single touch method and what is double touch method. Read well the portion, and if there is any doubt you can contact me. Thank you.